بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Dear students of the General Secondary Certificate, welcome back to your program مدرسة على الهواء. Don't forget to get your copybook, your pen and your calculator. Today inshallah we'll discuss the iron, continue our discussion about our syllabus, the iron. Before starting, let's first welcome your guest and my guest, Mr. Muhammad Abdullah Riyad. Welcome back, Mr. Muhammad.
Welcome.
Today inshallah we'll discuss the iron. Actually we need you to remind our students with the electronic configuration of iron, its properties, its importance, its reactions. Okay, let's start.
Okay, let's start with the electronic configuration of iron. We know that iron atomic number 26. It will be according to the electronic configuration: argon 18, 4s2 and 3d6. So it has 6 electrons in the sublevel 3d. At first, let's know an iron is found in the Earth's crust. It is the fourth element in the Earth's crust. We know that the elements in the Earth's crust, number one is oxygen. Oxygen is found in the Earth's crust about 50%. It is found not as a gas, but as a compound: oxide, carbonate, bicarbonate, sulfate, nitrate. All these salts and these oxides contains oxygen. Then silicon, as we know that silicon dioxide, sand is a silicon dioxide. Number 3 is aluminum. And number 4, iron. Oxygen, silicon, aluminum, and the fourth one in the Earth's crust is iron. But iron is the active element, so it is not found in free state. Iron may be found in free state only in meteorites which come from the sky. But in the Earth's crust, it is found as the source of oxides or compounds. The most ore of the iron ore, in order to consider this compound as the ore of iron, must be 3 points. Number 1, this compound must have high percentage of iron. Number 2, less impurities. Number 3, less harmful in this stone or in this ore, such as silicon or phosphorus or tin or whatever. So the 3 points in order to consider this compound is ore, it must have high percentage of iron. Some compounds maybe has less percent, such as pyrite. Pyrite, we know that it is an ore used in making sulfur, but it has a small ratio of iron, so iron is a byproduct. We use pyrite in order to get sulfur. But the ore of iron must have high percentage of iron. Number 2, less impurities. Number 3, less harmful substance in this ore. The most important ore in the Earth's crust, number 1, hematite. Hematite is iron 3 oxide, Fe2O3, iron 3 oxide. According to the configuration of the iron, we know that it has 2 electrons in 4s and 6 electrons in iron. So it may be has the valence 2, valence 3 or more. The compounds which has more than valence 3 has no importance. So the most important valency of iron is iron 2 and iron 3. When the iron is iron 2 Fe positive 2, it means that argon 18 and lose the 2 electrons of 4s 3d6. But iron 3, it is the more stable. Why? Yes, we said that when the sublevel D is completely filled or half filled or empty, it will be more stable. As we said before, in 3D contains 5, half filled more stable, so iron 3 is more stable compound. The ore number 1, hematite Fe2O3, or it is called iron 3 oxide. The number 2, limonite, it is a hydrated iron oxide, Fe2O3, 2 molecules combine with 3 molecules of water. Because this oxide has water, it is called hydrated iron 3 oxide. Iron 3 oxide, limonite or hematite, is found in ices. It contains percent of iron. Limonite has from 20 up to 40% of the iron, while hematite has more percents, I mean 50 to 60% of the iron. Hematite has a red color, while limonite is a yellow color. Number 3.
Actually, sorry for interruption. Before transferring to the next ore, I need to remind my students with something. The formula about limonite.
Yes.
Take care about the numbers that your teacher write on the data show here. We write 2Fe2O3 dot 3 water. Don't forget the 2 before the molecule and 3 in the water. Why? Because sometimes in the choose question he changes to you these numbers, make you confused. Don't get confused. Remember that Fe2O3, before the 2 we write 2, and after the 3 we write 3. Before the 2 we write 2, after the 3 we write 3. Don't forget this information because it is very important. Actually, another thing I need you to have a stress on, which is iron, as your teacher said, it is the 4th one in the earth crust, in all elements of the earth crust. Oxygen, then we said before, then we said silicon, then aluminium. Okay, it's the 4th one in earth crust in all the elements of earth crust. 4th according to the abundance, its ratio about 6.3% according to the mass. But this ratio make the iron the first abundant element in transition elements. So it is the first one in transition elements, most abundant in transition elements. But in the whole elements in the earth crust, either transition or any other element, it is the 4th one. It differs completely. 4th one in all element and the first one in transition elements. And don't forget this, this is the second note about our explanation for this lesson. Sorry, Mister, for interruption, but I have these points making confusion to our students.
Okay, let students to know that oxygen not a transition element, silicon not a transition element, aluminum not a transition element, then iron, then calcium number 5. We studied before the 6th one, sodium and potassium, and then phosphorus, then the rest of the elements. This is the all elements in the earth crust. This is number 2, limonite, hydrated iron 3 oxide. Number 3, magnetite. Magnetite Fe3O4. It is called black oxide or magnetic oxide. It has black color, so it is called black oxide, and it has magnetic properties. It's called magnetic oxide. it is not iron 2 or iron 3, but we know that it is a mixture of iron 2 and iron 3. Magnetite Fe3O4. Number 4, siderite. Siderite FeCO3, iron 2 carbonate. Iron 2 carbonate FeCO3. This is about the most important ore of iron. Okay?
Now let's transfer to the next point, which is how can we extract iron from these ore that you introduced it to us. Which ore we will deal with? All of them. You said before the percentage of the iron, the impurities nature, and the nature of the harmful materials in it is the basis upon which, or the basis upon which we choose the best ore.
Yes.
So how can we extract iron from the ore, and which ore we will focus on in our study?
Extraction of ore iron from ore. This takes extraction of iron from ore. This takes in 3 steps. 1, 2, 3. The first one, to prepare the ore in order to get iron, to improve the physical and the chemical properties of ore, that is called ore dressing. Number 1, ore dressing. Dressing meaning that improve the impurities, physical and chemical and mechanical properties of the ore in order to be in suitable form for reduction in the furnaces. So the second step is reduction of ore. Reduction of ore. How to get iron from this ore. The most important ore will be hematite, and all type of iron, as we will see in the dressing, at the end they are converted into iron 3 oxide. And last step, producing iron, different iron, and producing steel. Let's explain the steps of this extraction. This is called meteorology. Meteorology meaning that how to extract, or the branch of chemistry or branch of science to extract metals from their ore. Meteorology. In order to extract iron from ore, the first step we say that dressing, ore dressing. I said that dressing to improve the physical, chemical, and mechanical properties of the ore. Number 1, I will explain dressing. Number 1, improve physical and mechanical properties of the ore. In order to improve this, the physical and the mechanical properties of the ore, this occurs, or this includes 3 steps. Number 1, crushing the ore. Crushing ore. Crushing meaning that the massive particles, or the big particles, are converted into small particles. But crushing means that to convert big particles into small particles. Number 2, sintering. sintering, in order to convert الباودر, very fine particles, ash comes from the furnaces of the iron. These are treated and collected together to be big, homogeneous and similar particles in order to be in a suitable form for the furnaces. This process is called sintering. Sintering means that treatment الفاين particles ash comes from the furnaces in order to convert it to very big or more big one, يعني small, not very big, more big one, and in the form of suitable for furnaces. This process is called sintering. Then last step, number 3, concentration. Concentration, get rid of impurities mixed with the ore in order to increase the percentage of the iron. And the concentration may be, we can use this, some method such as surface tension or mechanical separation or chemical separation or electric separation. This is a method used to separate impurities and to be increase the percentage of the iron. This is the third steps in number 1, improving the physical and the mechanical properties. Number 1, في الore dressing, I said that to improve the physical and the mechanical properties, and this occurs in 3 steps. Number 1, crushing, convert big into small particles. Number 2, sintering. Sintering means fine particles ash powder and converted into small particles or more big than the powder. And the last one, concentration, which occurs by surface tension or electric and mechanical separation. This is the number 1, improve the physical and the mechanical properties. Number 2, I said that to improve the chemical properties. The second step in dressing, improve chemical properties of the ore. Chemical properties. To improve the chemical properties, we used roasting. The process is called roasting. As you know, roasting is the strongly heating iron ore in the air. Roasting means that strongly heating iron ore in the air. يبقى roasting, strongly heating. الأور in the air. This is why, in order to, number 1, get rid of humidity, to dry the ore, get rid of humidity. I will explain by equation. Number 2, increase the percentage of iron in the ore. Number 3, get rid of impurities. Get rid of impurities. Let's start by the first step. How to get rid of humidity from the ore. We know that limonite, as we said, that 2Fe2O3.3 H2O. By strongly heat, the water evolves and 2Fe2O3 plus 3H2O. So we get rid of water. Number 2, how to increase the percentage of the iron? By roasting. If the ore is siderite, FeCO3, what's the effect of it? We know that the effect of it on carbonate, as you know, it will give iron 2 oxide and carbon dioxide. Iron 2 oxide, due to the strong heat, it will be Fe2O3. Iron 2 oxide is oxidized to iron 3 oxide by strongly heating in the air. The percentage of iron in FeCO3, 48.5%, while the percentage of the iron in Fe2O3, 69.6%. Here we increase the percentage of the iron from 48.5 to 70 or 69.6%. But the number 1 from roasting, get rid of water or humidity as we convert hydrated iron 3 oxide into iron 3 oxide. Number 2, increase the percentage of the iron because the FeCO3, which contains about 58%, 58.5% of iron, at the end converted into Fe2O3, which contains 69.6% of the iron. The last step.
Actually, I have a question here. Dear students, take care of it. We have a question come in the previous exams of the General Secondary Certificate. He said to you, choose on strong heating of iron 2 carbonate in air. The product is FeO, Fe2O3, Fe3O4. Actually, the answer is, as you said before, it is Fe2O3. Your teacher said to you that it's heating, then strongly in air. So the question merged the two the two equations in one question. He said to you, heating siderite strongly in air. So you must do the two equations together. Iron 2 carbonate by heating, it gives iron 2 oxide and CO2. Then the iron 2 oxide strongly in air gives iron 3 oxide. So take care about this question. Again, the question said that on strongly heating siderite in air. In air means in the presence of oxygen. Sorry for interruption, teacher, but it's a very important
question. As we know, iron 3 oxide is more stable than iron 2. So FeO, it will convert into Fe2O3 to be more stable. I said that iron 2 6 electrons in D sublevel, while iron 3 بيبقى 5 electrons. It's more stable. So at the end, the iron 2 oxide or FeCO3 are converted into Fe2O3.
Actually, in the limonite also, as you said before, the roasting increased the percentage of iron in the ore. In the limonite, the iron was 40%. By heating and expelling humidity, as you said before, it becomes iron 3 oxide. So the percentage of iron becomes 69.6%. So this increased the percentage of iron also. Yani heating limonite increased the percentage of iron plus expelling the humidity or get rid of humidity.
Because the percentage of the iron in limonite don't exceed 40,
Yes.
20 or 40. Number 3, get rid of impurities. As we know that of the ore contains sulfur as a solid substance or phosphorus, also solid substance. By strongly heating, react with oxygen. The active gas in the air is the oxygen. By strongly heating, sulfur combines with oxygen to form SO2, sulfur dioxide gas, and evolves. Also, phosphorus, By strongly heating it, combine with or react with oxygen to form phosphorus pentoxide, 2, 4, and 5O2. Phosphorus pentoxide also can be evolved. So we get rid of this impurity. So the first step, as we said before, extraction of iron, on the first one is the ore dressing. Ore dressing meaning increase, meaning improve the chemical, physical, and mechanical properties of the ore. On the ore dressing, on the two steps. Number one, improve the mechanical and physical properties by the three steps: crushing, sintering, and concentration. Number two, increase the chemical by roasting. On roasting بيبقى ليه three aims. Number one, get rid of humidity. Number two, increase the percentage of the iron. Number three, get rid of impurities.
Could we make a map?
About only one point.
Okay.
If this ore can Fe3O4, also by strongly heating iron magnetite or black oxide, by oxidation it also converted into Fe2O3. We will know that this has more percent of oxygen. This is the higher oxides than Fe3O4. This is 3 and this 2.5 oxygen. So all type of ore will be converted into Fe2O3. Okay, I'm sorry.
Never mind. I need to make. Could we make a map for all the processes takes place as in the previous sketch that you did on the data show? Yes. We can get. We explain ore dressing. Get 2 arrows as you draw here. The first one, improving the physical properties.
Improve the physical.
And the second one, improve the chemical. Yes. Then about the improving the physical, we can get 3 arrows: crashing, centering, then concentrating. So this map just make an illustration for our students.
Number one,
crashing.
We need a small pen. Crashing, sintering.
Yes. Then
purification or concentration.
Excellent. The chemical, roasting only.
Chemical roasting.
This is the first step that you already explained.
Okay.
So it's a map. Show the student what are the points that we are discussing. We start with the extraction of the iron from the ore, and then we said that it happens on 3 steps. The 3 steps are ore dressing, then number 2, reduction, number 3, steel production or iron production. The first step, ore dressing, it has improving the physical properties and improving the chemical properties. Improving physical properties happen through 3 processes, which are crushing, centering, and concentrating the iron in the ore. The second step, or the second process, chemical, improving the chemical properties, happen via one process, which is roasting. Okay, and we said that the roasting aims to expelling humidity, increasing the concentration of iron in the ore, and to get rid of impurities. Then let's transfer to the second process in the iron extraction from the ore, which is reduction. Actually, the reduction happened via one of the 2 methods, via choosing reducing agent carbon monoxide or carbon monoxide and hydrogen mixture. After we finish, we can show it on the map for the students.
Okay, a reduction depends on the type of furnace, depends on the type of reducing agent. It may be carbon monoxide, as in blast furnace, or mixture of carbon monoxide and the hydrogen, which is called water gas, as in matrix furnace. Here the blast furnace, and here matrix furnace. Let's explain a reduction of iron ore.
And please, after we finish, shall we make a comparison between blast furnace and matrix according to the new information in their book? Some information have been expelled, such as the charge or whatever. make just points about the reducing agent, oxidizing agent, the type of the produced iron, the equation in the blast furnace and in the matrix
But
furnace.
the type if produced, I think it is not found in the new cells.
Yes, I know
I
that.
will explain
just
it.
yes, thank
Well,
you.
Number one, reducing agent. It is a substance which can take oxygen from ore, and convert. We need to convert the iron ore, as we said, Fe2O3. We need to convert it into Fe to remove oxygen. So reduction means converting the ore into iron. The reducing agent may be number one, carbon monoxide, CO. Carbon monoxide can convert the ore Fe2O3 into iron. We use a big furnace. It is called blast furnace. But carbon monoxide, we use it in a reducing agent in blast furnace. Blast furnace. How to get at first carbon monoxide? In blast furnace, the charge in blast furnace is carbon and ore and limestone. Let's to say carbon and ore. Carbon and oxygen by heating gives carbon dioxide. Then carbon dioxide reacts with more amount of carbon to form carbon monoxide, which is a reducing agent. So in blast furnace, carbon monoxide is formed inside the furnace. Why? Because we put the charge of the blast furnace is carbon with ore. The carbon combined and the oxygen also is found inside the furnace. Carbon combined with oxygen to form carbon dioxide. Carbon dioxide combined with carbon to form carbon monoxide, which is reducing agent. And I said that in blast furnace. Take care. Ore Fe2O3 combined with carbon monoxide, reducing agent, by strongly heating over 700 degrees Celsius. Carbon monoxide takes oxygen to give the iron and carbon dioxide. Carbon monoxide is oxidized to carbon dioxide. But let's do, I said that balance. It is very important to balance the equation. Here we want to get rid of 3 oxygen. So we get 3 carbon monoxide to get 3 carbon dioxide and 2 Fe. I said this is in a furnace called blast furnace. It is found in Helwan. The last reducing agent is water gas. Water gas reducing agent. Water gas. Water gas, carbon monoxide, زائد hydrogen. Mixture of carbon monoxide and hydrogen. We can get water gas from methane, natural gas. We know that the natural gas, we can get it from Abu Qir. So matrix furnace is found in Alexandria. Matrix is found in Alexandria because we need methane gas in order to get water gas. How can we get water gas from methane? Methane contains, natural gas contains about 93% of methane, which is CH4. Methane. We will study methane in organic chemistry. CH4 plus carbon dioxide plus water, it gives carbon monoxide and hydrogen. Carbon monoxide and hydrogen. This mixture is called water gas, and water gas is the reducing agent in matrix furnace. We will balance this equation. Matrix furnace. 2, 3 carbon and oxygen 3 oxygen, hydrogen 2 4 by 8 يبقى 5 O2. This is how to get a reducing agent in matrix furnace. The reaction between oxyhost gases comes from this furnace, which is carbon dioxide and water vapor, can enter in a closed cycle to react once more with methane to get a water gas. The water gas will reduce the ore. يبقى reduction of ore in matrix using water gas Fe2O3 plus carbon monoxide plus hydrogen. It gives Fe plus carbon dioxide plus water vapor evolve. We take here 2 to get 3 CO2 with 3 lil H plus 3 water and 4 iron to balance equation. So we convert the ore, which is Fe2O3. We said that after dressing, yes, all the type of ore are converted into Fe2O3. Fe2O3 can be reduced using water gas, which is the mixture of carbon monoxide and the hydrogen, as in matrix. And we can use carbon monoxide as a reducing agent as in blast furnace. Blast furnace, I said that a reducing agent is carbon monoxide, and it gives a cast iron. It gives a cast iron. While in matrix, which is found in Alexandria, a reducing agent is a water gas, a mixture of carbon monoxide and hydrogen, and it gives a spongy iron. This is about the matrix furnace and blast furnace. Number 3. نرجع number 2 للبلين اللي احنا قلنا عليه، المس قالت عليه. Yes.
Just to show us, yes,
okay, again,
make a map for the students.
Again, we say that the ore dressing خلاص. Reduction of ore on 2 reducing agent, carbon monoxide as in blast furnace. This is the carbon monoxide. Here, carbon monoxide in blast furnace, and the mixture of carbon monoxide and the hydrogen, which is called water gas, in matrix furnace. Carbon monoxide in blast furnace, where water gas in matrix furnace. So we can use another furnace. Here another furnaces similar to blast, but less. We know that blast furnace, our knowledge about blast furnace is a high furnace, about 30 meter. But there are a small furnace than blast furnace to get the type of ore called a big iron comes from blast, and then we convert into cast iron. And also another furnace is used to get steel. So we said that again, from blast furnace we get pig iron, and another furnace used to get cast iron. This is the type of iron, cast iron. Or we convert matrix in order to get a spongy iron. But actually we need to convert the iron into steel. Steel, iron steel is a strong type. We know that iron, brittle, can be oxidized and exposed to rust. So we convert it into very hard one, steel, or as we explain about the alloys. How to get steel? Reducing steel. Steel, there are two important processes in order to get steel or to convert the iron into steel. Number one, get rid from impurities mixed with the iron which comes from blast furnace or matrix furnace. Number one, get rid of impurities. The process occurs inside the furnaces of producing steel. At first we get rid of impurities mixed with the iron which comes from blast furnace or matrix furnace. Number two, adding a wanted substance. A desirable substance in order to get certain properties of steel according to the type of industry. This is steel for tools, for weapons, for whatever the type of the uses, or for building like reinforced steel. So we must add some elements needed to get a certain properties of steel according to the uses of this steel. This is a two process in order to get steel with a certain character. Steel with a certain character. What are the type of the furnaces used to get steel? We have three type of furnaces. Furnaces of producing steel. Number one, an oxygen converter. Oxygen converter. An oxygen converter contains oxygen. We put the pig iron which comes from blast furnace to oxygen converter in order to get rid of impurities by oxygen, to oxidize the impurities, and then we add the wanted substance in order to get a type of steel. Number two, an open hearth. Open hearth furnaces of Siemens Martin. We put sponge iron comes from matrix in open hearth or Siemens Martin to get a steel. Number three, an electric furnace. In electric furnaces, they are used the rubbish and the broken iron and old iron in electric furnaces to get out to convert iron into steel. This is the three furnaces to get steel.
Actually, by this point we finish iron.
Yes.
Transfer to the next point in our lesson, which is the alloys.
Alloys.
We said before the iron produced from the reduction process, so brittle, has no industrial uses. So to put it in the form of industrial use, we must make it steel. So in one of the furnaces that you mentioned, making steel means that we will add to iron some desirable characters by adding or by controlling the percentage of carbon in it, right? According to the use in the car chases, according to the use, as you said before. Let's transfer to the alloys. Actually, what are the alloys?
What's meant by alloys? What are the alloys? Alloys is the mixture of two or more elements by certain ratio to get certain character. يبقى mixture of two or more elements to get certain properties or certain characters. Certain properties. according to the usage of this one.
How to prepare alloy? Generally, we have only two methods to
Yes.
prepare alloy. We said melting or electric deposition. Shall we explain it to our students, please?
Number one, melting. By melting the two or the elements, melting them and mixing them together. When we cool them, when we let them to cool, they form alloy. And when we mix it, the molten iron, okay, with the molten manganese, it will be ferromanganese. This is the first step, by melting the two or the elements of the alloy. Number two, electrodeposition.
Actually, electric deposition will be explained in details in chapter 3 in chapter 4.
Chapter 4.
In our syllabus, yes.
Okay. By using electricity, بنعمل deposition of the two elements. We will explain this in chapter 4. This example, the iron hands of doors can be converted by what's called brass. By electrodeposition, we use a mixture of zinc and copper.
Yes.
To make the brass. This is in the it cover the iron handle of doors.
And actually, dear students, take care about the brass alloy, because sometimes in our exams we obtain to you a question said that the brass alloy is a mixture of zinc, copper, zinc, let's say iron and zinc, iron and copper. Take care, the brass alloy, it's a mixture of copper and zinc. Take care about this, because after a while we'll have another alloy called bronze alloy. Bronze, it's copper and tin. Copper and zinc, Cu plus Zn, it's brass. Copper and tin, Cu plus Sn, it's bronze. Bronze, tin, Sn. Brass, zinc, Zn. Take care about these two alloys, because they make a great confusion to our students in the answers. Sorry for interruption, mister.
Okay. What?
Now we finish the preparation. Let's transfer to the types of alloys. Shall we make it like a comparison to our students quickly, because of the time of the session? What are the three types of alloys?
Okay, the three types of alloys. Interstitial alloy. Interstitial alloy. Number two, substitution alloy. Number three, intermetallic alloys. Intermetallic alloy. In order to make a comparison, first comparison between these, if the two elements are different in properties, are different, such as mixture of iron and the carbon, without any combination, without any bond, this is called interstitial alloy. If the two elements are similar in diameter, similar in chemical properties, similar in crystal form, this is called substitutional alloy. As we say that Fe, مثلا iron والمنغنيز, ferromanganese, ferrochromium. If the two elements are different in properties, they are from different groups, are different from, but they make a chemical bond between them. This is called the intermetallic. Maybe nickel and aluminum and I3Al, nickel and aluminum alloy. These are two elements differ. Nickel is a transition element, pi representative element, aluminum. خلاص. This is called the intermetallic. Intermetallic عبارة عن solid, different properties, and the chemical bond occurs between them, and this bond disorder the valence of the rule of valency. Cementite, Fe3C, iron is a transition while carbon is not a transition. خلاص. This is called intermetallic. And solid chemical bond occurs, they don't obey the rule of valency.
Actually, the nickel aluminium is called duralumin alloy.
Duralumin.
We
yes.
have also gold lead alloy, which is Au2Pb.
BB.
Yes,
Lead gold. Au2
Pb.
BB.
Yes. So this is the
valency
intermetallic.
differ. Yes.
Substitutional, as you said, copper gold alloy. The two elements have the same crystalline structure, same properties, and the same chemical properties,
Yes.
and in the same group in the periodic table, and have the same size or diameter of atom. This make a substitutional alloy. We make atom removed from the crystalline structure of the main and put the new one in its place. While in the interstitial alloy, we have intermolecular spaces. The atom, the new atom, enter in the intermolecular spaces, so its size must be smaller than the intermolecular spaces to fit this new space, such as
if the added atoms bigger than the
it will make
pure
distortion.
atoms, I mean this
Yes,
formation.
and this addition change the physical properties of the element.
Physical and chemical
Melting.
properties. Okay.
Yes, thank you.
Okay.
Thank you, Mr. Muhammad, for being with us. The time passed away very fast.
You are welcome.
Thank you, dear students, for being with us. We'll wait for you for the next session. Assalamu alaikum wa rahmatullahi wa barakatuh.